Hey, think about the last thing you did online. Maybe you were sending a message, watching a video. Whatever it was, I bet you don't think much about where that technology came from. Well, its origin has nothing to do with connecting people. It was born from the fear of total war.
Yep, you heard that right. The very network that brings you cat videos and lets you talk to family across the world, it was originally designed as a weapon, forged in the intense pressure of the Cold War.
Okay, so to really get this, we've got to go back. Let's rewind the clock to a time of just incredible global tension, when the world was basically split in two between these giant superpowers.
It all starts in 1949. The Soviet Union tests its first atomic bomb, and the fear in the United States is just palpable. Then, in 1957, that anxiety skyrockets. The Soviets launch Sputnik, the first ever satellite, and it's a huge shock. It proved they could potentially strike America from space. So the U.S. government responds by creating ARPA, the Advanced Research Projects Agency. This was a team of geniuses with one single goal: make sure America never, ever gets caught off guard by technology again. And this is where a brilliant engineer named Paul Baran enters our story.
This was the absolutely terrifying question dropped in Baran's lap at the Rand Corporation. See, their current systems were dangerously fragile. If the bombs ever started flying, how would the president give orders? How could the military possibly coordinate a response if their communication lines were just gone, wiped off the map in the first few minutes?
And this critical, high-stakes question led to a truly revolutionary idea, one that would change how information travels forever.
See, back then, the big problem was centralization. All communication, and I mean everything, from phone calls to military commands, ran through these big central hubs. Think of those old-timey telephone operators physically plugging in wires. Well, a single attack on one of those hubs could knock out communication for an entire region. It was a massive, glaring weak spot, the network's Achilles heel, for sure. Paul Baran's solution was pure genius. Instead of sending one big, vulnerable message, he proposed chopping it up into hundreds of tiny pieces he called packets. Then, you just release all these packets into the network, and each one finds its own path to the destination. They'd act like cars navigating a city grid, right? If one road is blocked, they just find another way around. A bomb could take out a whole chunk of the network, and it wouldn't matter. The packets would just reroute. No central hub, no single point of failure. The network could take a direct hit and just keep on working. Okay, so this decentralized design was brilliant, but it created a whole new and very messy problem. They had built this super resilient highway, but the cars were arriving in a total jumble. Imagine you send a text that says, "We are in trouble, send help," but your friend gets a message that says, "Help, trouble in, send we are." Or even worse, what if some of the words just never show up at all? That's the exact problem they were facing. The information was getting through, but it was so out of order and incomplete that it was basically useless. The solution came from a pair of protocols developed by Vint Cerf and Robert Kahn, which act as the Internet's universal language. The IP part, Internet Protocol, is like a postal address. It stamps each little packet with its final destination. But the real magic is the TCP, the Transmission Control Protocol. That's like a super organized logistics manager. It numbers every single packet, checks to see if they all arrived safely, and then puts them back together in the correct order. Together, TCP and IP brought order to the chaos. All right, so by the 1980s, we have a network that's robust and reliable. But there was still this one huge problem. It was basically unusable for anyone who wasn't a computer scientist. Imagine for a second that instead of typing google.com, you had to remember and type something like 142.250.190.78. That's what it was really like. You had this powerful library with no card catalog and no book titles, just a massive collection of long, impossible-to-remember numbers. And this brings us to a scientist named Tim Berners-Lee. While working at the CERN physics lab in Europe, he created 3 innovations that would become the World Wide Web. First up was HTML, which is a simple language that lets anyone create a web page with text, images, and some basic structure. Next, he created the rules of the road for these new web pages. He called it HTTP. It's the protocol that lets your computer ask a server for a page, and then lets the server deliver that page right back to you. It's really the engine that makes the whole web move. And finally, he solved that awful number problem. URLs gave every single page on the internet a simple, memorable, text-based address.
All of a sudden, you didn't have to be a computer genius to find your way around. You could just click a link.
Now, here's what's so crucial about this. Tim Berners-Lee could have become one of the wealthiest people on Earth. But instead, he gave his invention to the world for free. He insisted that it had to remain an open, decentralized platform, not controlled by any single company or government. And he founded the World Wide Web Consortium, or W3C, to act as its guardian, to make sure it would always stay open.
And this brings us right to the central tension of the internet today. That founding ideal of a free, open network versus the modern reality of surveillance and control.
It's pretty ironic, isn't it? The internet's decentralized design, built to survive a physical attack, is now in a battle against a totally different kind of threat: digital control. On one side is that vision of open access for all, but on the other, you have things like China's Great Firewall, which blocks huge portions of the global internet, and widespread government surveillance that just erodes the very idea of privacy.
And this conflict is not theoretical. After Yahoo handed over a Chinese journalist's email data to the government, which led to a 10-year prison sentence, a U.S. judge aimed these scathing words right at the company's executives. It just highlights the immense pressure corporations are under to comply with state demands for control. And let's be clear, this isn't just an issue in authoritarian countries, not by a long shot. As this slide shows, the documents leaked by Edward Snowden back in 2013 exposed the shocking scale of mass surveillance by Western governments on their own citizens, which fundamentally challenged the idea of a private, open internet for everyone.
So this brings us full circle. The internet's core architecture was built for survival against one kind of existential threat. The question for all of us today is whether that same design can help it survive a completely different one, the battle for its very soul.